All right, good morning again. Everybody have a good evening? Enjoy the nice weather? I am astounded by our decent weather. I actually saw a lot of people out on motorcycles, but I thought about taking mine out, but apparently somebody had forgotten to take the battery tender and actually plug it in, so it was dead. That's kind of the way we work here. So, a couple of things. We kind of left off with this idea that we can use these shortcut operators. You are certainly welcome to do those. Make sure that you remember that our computer, and I know I'll harp on it a lot, but it happens. And even those of us who've been doing it for a while will suddenly forget that, yep, the computer starts with 0 and not with 1. So we have this ability to do a lot of formatting of our output of our data. So in this case, we can actually edit some of this in terms of how big we want our data. And so we actually have a format command, which is kind of handy. So I would encourage you to practice and use the format a little bit. So this gives us some abilities to format data how we want data to be formatted. So we can specify a width or a precision. So if we're doing data where we want it to actually show 2 decimal places, so here we have a $sign and we're going to string of salary, and it says salary is 100.0. Well, what we really want to do is display 2 decimals. So we can use that format as a really easy way to do that. We started looking at if-then-else statements. Excuse me. So, comparison operators that we've got so far, we've got the not equals, which we use a significant amount of time. We've got a greater than, less than, greater than or equal. So, a lot of times we have to be careful with these greater than or less thans to make sure that we actually are looking at the correct piece we're looking at. So we started looking about this idea of if statements and else statements. So a quick way to look at it is something called a flowchart. And so we haven't looked at this a whole lot, but it makes sense that a flowchart, we know we have a couple of designs that we're going to use. So one of them is when we come down and we have a diamond, the diamond is always a decision. And for our purposes here, and for what we're working with our computers can only make 2 choices. Really, yes and no, because they're binary. They can only do 1s and 0s. So we can output something that's true or output something that's false from this decision. So if that decision is true, we can run a set of statements. If it's false, we can run a different set of statements. And we looked really briefly at some of those. And we said, all right, if a condition A is true, and I did an Excel spreadsheet where we looked at did you pass a class based on greater than or less than 70%. Well, the question is my grade higher than 70%? If that's true, then we print, hey, you passed. If it's false, then you print, hey, you failed this class. And then it returns back to this mainline programming logic. So one of the things in all of our coding we're going to work towards is we start at the beginning and we work our way down all the way to the end of the program. So we're going to call that idea structured. In other words, we go through the program top to bottom. In a lot of languages, we can do some jumping around. And when I started, when I was a kid and playing around, we used a language called BASIC. And BASIC was really interesting because I could do some really out of sequence activities. And a lot of programming languages will do that. So if I have a start and a stop, so this is my program starts, my program ends. We really want everything, including our loops and everything else, to flow top to bottom. But so for example, in BASIC, I could just have a go-to, and I could jump up here to this line, and I could jump down, and it was very spaghetti-like. It didn't make a lot of sense. So we work really hard now to build programs that start at one end and stop at the other. We call it that idea of structure. And if we take out that entire program, we could actually insert it into another program because it's got a defined start and it's got a defined stop. So you're going to see that we run into this quite a bit. So if the simplest type of if statement we have, so here we have something that happens if this sequence is true, otherwise it just bypasses it. So,
question.
Yes.
I know the start or the stop that says push me to the exit. What are some of the other ones?
What are some of the other?
You just end program.
There's always or most programs have a graceful way to end the program. So, in our case, we're just going to show, we use that input to show that our program has come to an end. Otherwise, it just kind of crashes at the end. But usually what we're going to build, the size of the programs we're going to build, really we'd probably integrate into a bigger set of code. And you'll see as we develop what we're looking at there. So this is kind of a one-way statement like what we have here. So if temp is less than 50, turn on furnace. And so I indented it. So this is the same kind of code. We have a question. If the temperature is less than 50, we turn on the furnace. Well, if that's false, it just passes out, program is done. So this is an example of the easiest form of if statement. It only has, in this case, one decision. It's got a decision to make, and it's only a value that happens if it's true. So we indicate that those are in that blocks of code because maybe it also does something else. And maybe this doesn't make any sense, but we're going to lock door, and maybe we'll turn off lights. Whatever that set of structures is, that's all inside of this sequence right here. So we may want to test multiple conditions. So here we have the idea of I want letter grades. So they're doing it a little differently. So instead of saying 90 greater than or equal to 90, they're just saying above 89. So we also have some ways we can shortcut that. And so here, this is showing those grades. So we have a sequence of steps, a sequence of steps. So this is not truly a structured statement the way it's done. These would actually be nested inside themselves. So if I can find this, I put up another piece down here for us. And so I want to just look at this really quickly. So in our entire programming structure, we have 3 different types of content we can do. Every program is built out of these and nothing more. So our 3 basic structures: a selection, so we make a group that's in a sequence; a decision, so remember it's yes or no only; and a loop. And those loops are really based on our decisions. So this decision gives us either a if then else loop, so we can exit out, or here we have the ability to create a loop, and the easiest one we're going to do is something called a while loop. So our book starts out on the for loops. I want to make sure we understand a while loop. So a while loop happens while something is true. So if I look at my condition here, if temp less than 50, turn on the furnace, lock the doors, turn off the lights. But in this case, we wouldn't ask this question just once. Really what we would want to do is make this a loop. So while temperature is less than 50, all these conditions happen. And it comes down to the end of those, and then comes back up and checks that, is my temperature still less than 50? If it is, turn on the furnace, lock the doors, turn off the lights. Loops around again. Is it still less than 50? So that's the idea of we take this looping ability we've discovered and we combine it with a question, and now we can do things not with a specific number of times, but until the furnace has got enough heat that it's above 50, and then it will shut that furnace off. So this is our entry into a loop. We loop until that condition is no longer true, and then we exit out of that particular piece. So we have these three pieces. We have sequences, and we have, let me throw it up here so it's a little bigger and easier to see. So we can combine these different pieces. So we have an if then else, or just an if then. So we have a decision and we have a loop. So we started out with sequences of operations. Then we said, hey, we can do if thens. Now we're going to do a loop. With those three pieces, we can build any program out there. Those are the only elements. Those are the three Lego blocks we have. We have a sequence of activities. We have an if-then statement, in other words, a question, and then we have a loop. And almost always those loops are based on some kind of a condition. So here's an example. Here's our start. And so if we're actually doing flowcharts, this is our start symbol. The diamond is our decision, and our end is also going to look like that. So our end down at the bottom would look exactly like the start symbol. So we throw the dice. We move token the number of spaces equal to the sum of the dice. Well, we're playing a game. And then we ask some questions. Did the token land on go to jail? If so, we move the token to the jail square. If not, did the token land on chance or community square, or the community chest? If so, we follow directions. And then the last piece then says, well, no, and then we follow the rules for the token is being bought. So this one doesn't have as much detail. It's kind of a higher level, but it's really how we play Monopoly. So the other piece, so what I'm talking about, and this fits kind of into your question here, Chris, I have a start and a stop. But notice I also now am adding a start and a stop symbol to these other pieces here. So this program is a little more sophisticated and uses these modules. So here we have a housekeeping, a detail, and a finish up, that we've got an entire module that we call. So here we say, here we're going to put our declarations. We set our values equal to what we need them to be. And then we call the housekeeping function. In this case, the housekeeping function only says, I'm going to set the number to 10. And then once it returns, it comes back to its original spot. So it then asks a question. So is number greater than 1? Well, we set it to 10, so number is greater than 1. It comes into this detail loop. The detail loop says output the number, so it prints 10 on the screen, and then says number equals number minus 1. So it takes away a value. Comes back up here. Is the number still greater than 1? So this program loops until that value of number is equal to or less than 1. So it loops 10 times, prints out the value 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Once this loop no longer, this is a while loop, while this number is less than 1, then it comes down here and says, oh, we're going to go to the finish up. Finish up says output into program statement, and we're done. So this is an example of a little more complicated structure, but we're really working to do the same task. I could write this all without these modules. These modules just are kind of handy. If we do something over and over and over again, we use modules to do it. That way we're not writing in that mainline program over and over again. So there's a couple of other things we need to work on. And these are really that idea of other statements we're going to use. So we have to consider something called a truth table. And so Taylor's probably shuddering going, I've seen truth tables before. And you may have seen those in algebra a little bit. So we have a couple of other statements we can use. And so we can have and statements and or statements. So I like to show it on Excel just because I can make this big and we can actually record it really easily. Let me make that a little bigger. So and statements, so if I do an and really says both true equals true. So if I have a set of statements, and remember 1 is true, 0 is false, so we can look at it that way. So if I have a 1 and a 0 and I'm doing an and statement, that's going to equal a 0 or a false. If I have a 0 and I have a 1, that's also going to equal false. If I have a 0 and a 0, well, both of them aren't true, so again I have a false. But if I have a 1 and a 1, so in other words, truth and a truth, I'm going to get a 1. And it's the only way I get a true out of this entire statement. So that's how we make conditions. So sometimes we need a group of students. And if I think about it this way, we have a couple of conditions that we need to be true. So maybe to get a scholarship, you need to have a GPA greater than 3.5. And what other conditions have you seen on scholarships? Is it always just based on GPA? So, great. That's a great example. A certain number of credit hours. So there are scholarships that are only for juniors and seniors. So, and we might say credit hour greater than 60. And that would disqualify freshmen and sophomores. So both of those conditions have to be true. So I can think about it this way. So if I have a student with a 2.3 GPA and they have 75 hours, well, that's an example here where the GPA isn't correct, but they do have enough hours, we're still not going to give them a scholarship. Or if neither conditions are true, so they only have 59 hours and a 2.3 GPA, then neither condition is true. And so only in the case of a student who has 3.6 and 61 hours, now both of those conditions are true, and we can output that information. Well, we might have some other things we want to do. So the AND statement says both conditions have to be true to output a yes. Well, the other one we have is we have an OR. And so OR says one statement has to be true. and I can't spell true. So let's think about this one a little bit. So in this case, maybe we have a scholarship that has some requirements that are a little different. So this one says is for incoming freshmen. And incoming freshmen, they don't have a GPA, so we can't use that. So we could say a high school GPA greater than 3.5, or they have an ACT score that's greater than, let's go 29. So now, do they have to have both conditions true to get a scholarship? No, because there are certainly students who did really well in the GPA but had test anxiety and scored poorly on the ACT. Or there are students who sloughed off, got a 1.7, but they're really smart and they actually got a 35 on the ACT. So in this case, that truth table, and I'm just going to copy this really quickly. So in this case, that truth table looks a little different on my results. In this case, now, if either condition is true, I have people that can get this scholarship. So I can have either a high school GPA greater than 3.5 or they've got an ACT above 29. So we see these all the time where there's two conditions and two possible ways in. The truth table works a little differently then. So if somebody has a high school GPA of a 4.0, but in our case here, we've actually excluded ACTs because during this COVID, it's been hard to take the ACT test for a lot of high school students. So maybe they don't even have an ACT score. We're still going to give them a scholarship. Blew their GPA, but they have a great ACT score. Hey, you get a scholarship. Neither condition true. Well, no scholarship for you. And then if both conditions are true, that also leads to an output of a true. So these are a couple of the ways we start breaking down data and breaking down our results, and we use these ideas of and or statements. So think about things like, I need to register for classes. So to register for classes, there's a couple things that have to be true. So we put on an advisor hold. So advisor hold gone has to be true, right? And are there other things that are required to register? So you may get stopped to try to register because you have other holds. So hopefully none of you have had this, but if you have enough grades, probation has to be lifted. But I think the criteria right now is that your balance that you owe the school has to be less than $250. And then you can register. So if you haven't paid last semester's tuition, you're probably not going to get a register. So I'm going to put the same conditions down here. So this is hold, and this is balance. And so if the advisor hold is gone equals true, so here it's true, so it's a 1. But your balance is not less than 250, no enrollment for you because this is an and statement. Or here, your advisor hold, hey, you got rid of that, but your balance is less than 250, but oh, I still have an advisor hold. Nope. If neither's true, obviously we have that. So only when both sides of that and statement are true do you get to enroll. So there's ands and there's ors, and you'll see those as we start to construct a lot of these logical arguments that we have them. So this is an example of that. To have a great dining experience, the food must be good and the service must also be good. And we've all went out to eat and had good food, but the waiter couldn't find us and our drinks went empty. Bad service meant I didn't have a great night out of eating. I've also had indications where I had great service, the waiter was amazing, and the food was so horrible that I can't even imagine ever going back there again. So, I went to a Ruby Tuesdays for some reason. We decided to go there after some event. And a couple of years ago, they had a great salad bar, and it was a really nice place to eat. We walked in, and the first guess we had was that maybe we should change our mind was the carpet was so gooey with crap that your feet stuck and went squish. And I went, oh, this is not, well, let's give it a try, because, we're trying to be nice. We sat down, and the waitress was amazing and told us a few things to avoid, which is always a nice thing. But the food was, at best, mediocre, if not completely disgusting. The waitress was really nice, service was good, but the food was horrible. Am I going back into Ruby Tuesdays? Not for a long, long time. So that service was great though. I tipped the waitress very heavily because that food was good. All right. Let's look at a few things we have to do here. So, in your book, let's see, what slide is that, 26? So, this slide is also the same type of truth table, it's just drawn out slightly different. So, this is our ands, this is our ors. So, they also showed you a not. So the not we use quite a bit because it's an easy way on those loops to control them. So A or not A. So in other words, how do we deal with when we're asking the question of is something true? And if it's not true, then obviously it's false. If the not A is, and this is where it gets confusing, is A is not true, that means, hey, our false statement side of that equation is false. So you'll see that when we actually start on some of these, what we're looking at. All right, I'm going to go back to the assignments. Come on. All right, so a couple of things in here. There's some videos, and I encourage you to watch those. I can't record a video while I'm also recording the class, so I apologize for that. So I'm going to take a look at 3-1. If it will load here. Yes, that's great. And we're going to look at an assignment in here and see if we can work our way through slowly. All right. All right. So this one says we want to write a program that accepts the lengths of 3 sides of a triangle as inputs. And then based on those inputs, should indicate whether or not the triangle is an equilateral triangle. Oh. And then it says, hey, we have to use the triangle is equilateral or the triangle is not equilateral. Okay, so I'm going to look at my handy dandy notepad here. Normally I would actually just scratch these down on a sheet of paper, but for the purposes of this, it works really well to do that. So I know that I'm going to have all my normal stuff at the beginning, my statements about who I am, all those kinds of things. But it says accepts the lengths of 3 sides of a triangle. So I'm going to do this. I'm going to call it side A. And I'm going to say that's equal to 0 to start with. And I'm going to say side B is equal to 0. And side C is equal to 0. So I have 3 variables. I'm going to take all 3 of those in. And so then I'm going to input sides. So I have side A, side B, side C. So I have to figure out, is this triangle an equilateral triangle? So what is something unique about an equilateral triangle? What is special about it? Well, if I don't remember, I'm going to do a real quick search over there, and I'm going to say equilateral triangle. What does that mean? Oh, all 3 sides have to be equal. Well, I think I now have enough information. So I'm going to say, so side A, side B have to be equal, and side A and C have to be equal, and these 2 have to be equal. So I need to construct a truth table to think about that a little bit. So come back out of here, use my notepad. So I need to make some logic to say, if this statement is true, then a result. But I need to first wrap my head around how I'm going to do that. So I know that I'm going to have, and I'm just going to shortcut these. I'm going to say, so if A equals B, does that make sense? Side A and side B are equal. And so what other sides do I have? I haven't gotten C. So A equals C. Is that going to let me know if all 3 sides are equal? Or do I need to put in there and C equals B? So now we have 3 and statements in there. So it gets a little more complicated. But let's think about this for a second. Let me bring my triangle over here. So I am asking, is A equal to B and A equal to C? Okay. So if A and B are equal, our program is going to continue. But if we're doing an and, both sides of this have to be true. So if A and B equals, well, so let me put it as a truth piece here, and maybe that'll help make it a little bit. So in this case, I'm going to get hopefully a true for the first part. And then I have an and, A equals C, and if that's also true, is that enough to tell us if we have an equilateral triangle or not? So A and B are equal, and A and C are equal. So what we're really saying is whatever this value is equal to this value. So they're all true. So you can actually shortcut that a little bit, because if A and B are the same, it doesn't matter if I compare A or B over here, because we know they're the same. If they're not already the same, it doesn't even matter. We don't even need to run that because we've already said it's false, right? Because both sides have to be true. So if I make a comparison like this, and I say if A equals B and A equals C, then I can do a statement. So this is true, and we'd say it's an equilateral, is otherwise, we're going to do an else, because the only other option we have then is not equilateral. Or however I'll spell it at this particular point, trying to type up in top. So, you have 2 options that are going to display. if A equals B, A equals C, we come out and we say, yep, that's true. So let's see if we can apply that same thing then here into our Python and actually make it work. So I know that I'm going to need some variables. I know I'm going to need my name. And so in this case, I'm going to call those variables to make my typing life easier. I might just even say, well, let's just do it side A equals 0, side B equals 0, side C equals 0. This you can actually do without. It's just a house cleaning and something that I just tend to do. So I need to get those three sides in. So I need to actually ask for an input. Well, to do that then I'm going to say side A equals input first side. Yeah. I'm going to cheat just a second because I like to copy and paste. And then I'm going to just edit the next statement. So B and then C. So we're going to enter the second. Now, before I do anything else, I'm going to run it just to make sure that my program actually works at this point and I don't have an error. So 2, 2, 2. Now, I see right away that I want to make sure there's a space in there because it's going to drive me crazy. Space, space, space. All right, so I get three values. Well, I have a couple of decisions to make. Do I evaluate those as strings? Do I evaluate those as floats? Do I evaluate those as integers? And so the first thought comes to mind is, what is our user going to input? And we know that whatever they input is a string. We need to make those comparisons. So perhaps it doesn't make any difference. We're not going to do any other manipulation of this right now. But maybe we are. Maybe we want to put the area of this also as an output. If that's the case, I probably need to change this to a float. So in case they put in 2.5 and we didn't leave it as a string, so I'm going to change these all to float. And it may not change anything in this program, but maybe I also want to add in the area. So the area of a triangle here, of an equilateral triangle, we have a special formula. So the square root of 3 over 4 times a squared. So if I wanted to figure that out, I'm going to have to leave this alone temporarily as floats. All right. So let's think about our if statement. So if side A is equal to side B and side A is equal to side C, so we've asked both sides of that. Then we're going to do a print statement that says, go up here and just grab them, the triangle is equilateral. Copy, and look at that, I can paste that right in. Well, the other option then, so we can do an else, print the triangle is not an equilateral. So if this condition is true, so both A and B are equal and A and C are equal, that should, if my brain is working, give us this result. And so down at the bottom, I'm then going to have an input just so I get used to putting that in there. And I'm going to run this, and we're going to see what happens. Syntax error, line 10. Oh. I should talk and type at the same time. What have I spelled wrong in this whole thing? Side A, side B, side C. Oh, duh. So remember when we're doing comparisons, we have to use that double equal sign. So it's not assigning a value, it's actually checking that for syntax. Okay. We're getting closer. So if side A, have that variable right, side B, and side C. All right. So let's take this out for a second and see if it runs with just one side of that equation. And it's going to say, oh, invalid syntax. So why is it asking me if those are so? Enter the first side. All right. So I put the colon back in there that I had taken out. So I'm going to put in values. Now, in this case, that actually works because it says it's not, and we only have part of that in there. So let's see if we can figure out how to get the second part in there. So if side A and side B are equal, and so we can side A is equal to side B. So let's see if this works. And sometimes the only way to figure this out is we have to do some experimenting. So enter the first side. So 2, 2, 2. The triangle is equilateral. All right. So I want to do some testing though, because I'm not so sure that the program actually works as I think. So the first side, A and B, but I want to test the second half. So is it really checking whether side A and side B are correct? It says, oh, the triangle's equilateral. What have I done wrong over here? Does anybody see it? Do I ever check side C? Yeah. So this program would run as long as you put in the right values for the test, but so now let's try it. 2, 3. Triangle is not equilateral because it compared side A, so 2 to 3, and said, oh, nope, those aren't true, and it escapes out. So I'm going to go over here to my checks and see if this happens to hit the checks for as it ever so quickly shoves data in there. Go Cengage. All right. So it says, hey, there's a wrong answer. Test for sides measuring 222 and 123. All right, hang on a second. So why is it telling us that it's wrong? Well, I think when I'm reading their instructions here, the triangle isn't equilateral. Expected output. All right, so in this case, let's do this, because while this is a great common thing to do, I think it interferes with our ability for this to work at this point. Because I'm getting a weird end of file. All right, so although this was a better program, sometimes we have to adapt it to the situation. So now it's going to say, hey, it's correct. It measures both sides. I can turn that in. So could we add that third test if we wanted to in here? So if you don't believe math and that we can manipulate things around, so if A equals B and B equals C, then A equals C, whatever, we can actually do that test one more time. So side A, no, side B, side C, and we can actually test those directly. In this case, when we have two sets of AND statements, every piece of that has to be true. And we can test that. And you can test it with all kinds of different data. And only will this work. Now, what you've added here is extra processing time. So in a large program, this wouldn't make any sense to do this extra piece. Because this right here is really duplicated. Because we know that side A and side B are already equal. So if it passes the first half of this true statement, then we can make that second comparison. If it fails here, the program's smart enough, it doesn't have to test the rest of it. So it's going to exit out immediately because it's an AND statement. Already the first part is false, so it's going to say, nope, I don't have to do that. So just a little piece of how we structure that sometimes. So what I want to structure this, if I think a part of this statement is going to fail, I want to structure it so the most likely item to fail is first. We'll talk about that processing. Right now, it runs fast enough that we don't even notice it. No. So you can try it with all different kinds of numbers. Now, I made it mad by hitting an enter, and an enter just gave it a null character, and it can't convert null characters to content. So we haven't got to being able to fix some of those errors, but the other error, if I did an A in there for side A, it's going to go, I don't know what it's doing. Now, if I took out the floats, so now I'm just using that as a string. I can still make comparisons. Isn't that interesting? Because it's comparing the letters. So A. And it's going to say it's not an equilateral. And if we look back at those ASCII charts, capital A is not the same as lowercase a. So you can manipulate this around a little bit and try different things. That's what we want you to do. Try things on those and see if you can get them to function. I can get 3-2 to launch, and we'll at least peek at it really quickly. Slowly engage. There we go. All right. So this is also a triangle, and this has some interesting information. It says, all right, so now we're going to check to see if a triangle is a right triangle or not. So similar type of logic, but now we have to think about it in terms of a little different. The square of one side equals the sum of the squares of the other two sides. Good. So, in this case, so 3, 4, and 5. So 3 squared is 9. 4 squared is 16. 16 and 9 happens to equal 25. The third side, 5 squared, is 25. So we know that is a right triangle. So in this case, it says any of the three sides of the triangle could be the hypotenuse. The program should handle this appropriately. All right. So I'm going to take some of my detail from here and I'm going to see if we can figure out a different way to do that. So now we're not equilateral, we're a right triangle or a not right triangle. So we get side A, side B, and side C. We need to figure out if this program is, or that triangle is a right triangle. So what we're saying is side A squared equals side B squared plus side C squared. And what we want to know is if that is true or not. Because if it's true, then it's a right triangle. But I also have to consider two other possibilities. And so that is B squared equals A squared plus C squared. And I also have to consider a third possibility, that is of C being the hypotenuse, or the longer side. So C squared equals A squared plus B squared. So just shortcutting it, how we're going to do it in Python. So how could we do that to figure this out? There's a couple different things that come to mind, but what could we do to see if one of those conditions is true? So the first idea that comes to my mind is the hypothesis is always the longest value. Is there a way to figure out which one of these would be the longest value? Any ideas? So idea A might be we have to figure out the longest one of these. So if you looked at it, how would you identify which one of these is the longest? How does your brain compare it? So you would take the first item. Is 3 bigger than 4? No. So your brain says 4 must be bigger than 3. And then I would come down and say, is 4 bigger than 5? No. So 5 must be the biggest number we have. So 5 equals that hypotenuse. So that's one way. There might be another way we could do it. what if we used an or statement in here instead? So what if we said this, or using B as a hypotenuse, or C? So if it truly is 3, 4, 5, at some point are we going to get a solution in here that's actually equal, that's true? So we have 3 different pieces here, and an or statement says, so in this case, we're going to actually have 3 statements. So we're going to say, let's try A is the hypotenuse, and that evaluates to true, or B is the hypotenuse, evaluates to true, or C as the hypotenuse, evaluates as true. So I'm going to have values across here. So I need to figure out if multiples of these are going to work. So our or statement says this has to be true, or this has to be true, or this one has to be true. So if any of those are true, the whole statement evaluates as positive. So in other words, we have 3 items rather than 2, and this is going to evaluate the similar way. So in this case, one of those is positive, so the whole thing is positive. If it's in the second position, yep, still positive. If it's in that third position, yep, still positive. And then if none of them evaluate true, then it's going to be false. So the truth table for this gets a little more complicated to try to figure out that hypothesis, but I think we can make it work very, very similarly. So that's my hint on 3-2 before we run away today. I think that this might be the easier way to do it. The other way, honestly, you could go figure out which ones of those sides is the longest. So the way you might do that is you could change the values around and scramble them so you could reorder them in order so that A is always going to be the biggest. So think about it this way. So if, let me just throw it out here real quick. If A greater than B, we're not going to have to change anything. And A greater than C, we know that A is so we don't change any values. We could then say if B greater than A, then we flip those around. So then A equals A, and so we could just re-flip those numbers. So if that's true, then we go set or switch A and B. And then we would ask then if C, because we've already figured out which is bigger of A and B, is if C is greater than B, and we could actually flip through those, or greater than A, sorry. And then we would flip A and C. So think about it this way. So we have a set of numbers. So we have A, B, C. And they put in 4, 5, 3. So our program first says, I'm going to compare A and B. If I'm looking for whichever number is bigger, so I'm going to compare B to A. And so if A is less than B, then it flip-flops their values. Okay, so our program says 5, 4. And then we look at, is C greater than A? Because what we're trying to find is that hypothesis. If in this case it's not true, so it doesn't change that order. But what if it were 5 and 3 this way? So now we evaluate it, and it's going to say, oh, 5 is greater than 3, and it'll flip that back, that 5 and that 3. And now we know that that order, and so all we need to do, once we get this order, is then check, does this squared equal this plus this? So a couple of different ways you can do it. All of them are valid methods to do this. There's probably 13 others, honestly. And that's one of the fun things that we can do with some of these values, is there's not one right way to do that. So we can reuse some of our code for the first, second, and third side. And then we can evaluate it. All right, so on next week, we'll talk a little more about it, but try that. See if you can come up with a solution, and then I'll look in there and see what people have put in, and we will try to see if we can come up with some interesting solutions. My guess is you guys are going to come up with some that are far more engaging and entertaining than the way I've done it. All right. There are a variety of assignments. Make sure when you look at the discussion board, click on the right spot, that you do week 5's discussion board. So, no, it's not actually my birthday, but it is Valentine's Day next week. Roughly 6 months to my birthday, give or take or whatever. So, that's why we're throwing that in there, kind of a think about outside of it. You don't have to tell me details. Just tell me that you did it. So, everybody can get some extra credit. All right. If I allow you to turn something in late, let me go really quickly. Hell, let me get out of there so you don't see that. So, if I allow you to turn something in late and I've already got a 0 on it, I can't see that you've done anything in there in our Blackboard gradebook. It's a little primitive. If that is the case and it's still showing a 0, it's called an override grade, and I can't see anything. I have to go in and clear that override grade out. So, if you've turned something in late and I've allowed you to do so, you'll have to tell me when it's completed so that I can actually go out and clear that out. I don't get any indication that says, hey, these items are all due. Even if I look at the grade book, all it shows me is that override grade. So until I dig 3 or 4 steps in there. All right, any questions? All right, go out and enjoy the warm day because it's weird. We're still warm.